So we're going to learn about or review the one population mean sigma unknown situation. So in this case, we have a personnel department that's using an aptitude test to screen employees, potential employees. Right? And so what we have are information given or is information given about a mean. Right? So they tell us that we have a simple random sample. They tell us that the sample mean is 96, and we have other information. Then we get the test. Test this hypothesis against the alternative that the mean mark is less than 100. All right, so that's our question. The mean mark is less than 100. Yeah, I put a little question mark after that, just to keep, in the spirit of it being a question, right? But that's going to make it either a z-test or a t-test. Now, we might want to consider getting into the reasons before we actually make a statement of what the type of test is, but we're testing a claim about a mean. But we don't know sigma. All right, so that's going to make it a t-test. All right, so now we get into assumptions and conditions. The possibilities, you go back to the first page in this packet. Possibilities, or the things that we have to account for, are simple random sample, which they state explicitly in the problem, which is great. That makes it a condition because we know that a condition is really just an assumption that has been verified. All right, so simple random sample. Sigma is unknown, poor quality sigma. But the one thing they don't talk about is normality. So we have to make that an assumption because the sample size doesn't meet the requirement of being more than 30. So we're looking at an assumption that we're working with a normal distribution. All right. The test itself is pretty easy because, or at least, stating the characteristics of the test, the test itself is what it is. But we know that mu is going to be either equal to 100 or the alternative would be that it would be less than 100. Now that's going to correspond with a left-tailed test. They told us alpha is 0.01. The test statistic is based off the formula T equals x bar minus mu over S over the square root of N. All right. They told us that the X bar was 96. We know mu is 100. S was, I believe, it says right there, 5.2. And N was 13. All right. So we're going to compute 96 minus 100 over 5.2 divided by the square root of 13. So negative 2.774. All right, so negative 2.774. That's going to bother me. It looks kind of ridiculous, but we'll live with it. All right. So then we can compute the p-value associated with that. All right. So the p-value is, we're going to use the t. We got to figure out the area corresponding with this. So t-CDF. So second var's t-CDF. Your calculator is going to look a little different, but it's going to have the same ingredients. Lower, upper, and the degrees of freedom. So I'm going to put in like negative 100 You go extreme enough, you don't have to put, other values in, but I'm just going to do it. Let me store this in. I'll store it in as A. So then I'll do my TCDF negative 100 comma A, and then degrees of freedom would be 12 because 13 minus 1. The degrees of freedom is n minus 1. So enter. So I'm looking at, so again, lower, upper degrees of freedom, 0.00843. All right, so I'm just gonna make a little note to myself. P value is less than the alpha value. All right, I also need my critical value for T. All right, so we're gonna do that by using the inverse T. All right, so second vars, inverse T, and then it's a 0.01 with 12 degrees of freedom. So we're looking at negative 2.681. All right, so either way, we're getting the idea that we should be rejecting the null hypothesis. All right, so there is sufficient evidence to reject the claim that, now we're talking about the mean mark, whatever that is, score. So you can paraphrase any way you want as long as you get the idea across, but there is sufficient evidence to reject the claim that the population mean mark is 100 at the 0.01 significance level. Therefore, the claim that it is less than 100, it is less than 100. Probably wrote too small there, but it matters not. It is going to be true. All right. That extra line, it's irrelevant in this case because my templated conclusion actually answers the question. Test the hypothesis against the alternative that the mean mark is less than 100. So mission accomplished. So we got it done. All right. So, and there it is.